Hello everyone, and welcome back to Neural Networks from Scratch in C++. So I made a GitHub repo, and this is going to be where I'm going to be pushing commits for every single one of the following lessons. So I'm going to make a main file, and this is going to describe some of the learning objectives that I expect for the next series of videos. So I'm going to make a comment for every single one of these objectives, and then we're going to put some code below the comments. So some of these comments are going to be obvious, and then some are going to be what we're building up to and won't make 100% sense at this point in time, but they definitely will in a few videos. So our first comment is we need some data structure to represent matrices. We then need some way to print out matrices because we want to be able to test whether our matrix multiplications are correct, for example. Then we're going to code a naive matrix multiplication. I specify that it's naive because we're going to make it a lot faster afterwards. Then we're going to be separating the bias from matrix multiplication. So as I mentioned, not everything is going to make sense, and this is one of those things. And then we're going to be optimizing matrix multiplication plus bias. So you might be wondering why the bias separately. Well, as I said, we'll get to there. So let's start with the very first point. So we need some data structure to represent matrices. So in neural networks, all of the shapes we know ahead of time. So it's not like we have shapes that are dynamically changing during the runtime, or at least for the parameters of the network. These are known shapes. So because of that, it would be pretty, I guess the obvious candidate would be to use an array of arrays, and that's what we're going to be using. So I'm going to include nn.hpp, and I'm going to be implementing the function, these helper functions in nn.hpp and nn.tpp. So in the HPP file, we're just going to put the function definitions and then the implementations in the TPP file. So as I said, we want to use an array of arrays. So I'm going to be including array. And I'm going to make a function called createMatrix, which I'm just going to put ... for the type. And ... matrix, and we're going to be returning this matrix. So as I said, we're going to know all of the shapes ahead of time, so we don't necessarily need to pass in the shape as arguments to this function. We can actually template this function based on the data that we know about the matrix. So I'm going to make a template, and matrices have rows and columns. So we are going to template with, I guess, the number of rows and the number of columns. But there's one other factor. We need to know what is the type of the storage data. Like what is the type of each element in this matrix? And we can template this as well. So I'm going to be templating it by type name t. And this could be an integer, a floating point, etc. So now what does our return type look like? Well, as I said, we're going to have an array of arrays, and just remember, it's just a num rows by num c matrix. So we're going to have an array which represents every row, and then we're going to have an array that holds on to all of these different rows, right? So what we need is we need to represent a row. So what is the size of a row? Well, every single row is going to be of size nc, right? So if you have a matrix, I'm going to go, for example, to Excalibur. So here's a matrix. I'm specifying that it's 2 by 2, and then I'm saying that we have an array for every single row. Well, the size of this is going to be nc, and then we're going to have nr different rows. Hopefully that makes sense. So going back, I hope you liked my recommended music. Okay, so going back, we have to specify the container. So this is going to be of type T, and then we have to specify the size. So this is going to be NC, and then here we're going to have NR. Okay, and we can just copy that over here for the dot dot dot. Now specifically, we want to make we want to populate the matrix with some data. We're not just going to make a matrix with random data. So we could just make it here and then populate it elsewhere. But for simplicity, we're going to populate it here. And we're going to populate it in the easiest way possible using something called a range. So let's say I have a 2x2 matrix. So I'm going to specify it as a bracket, and then here is going to be another bracket for the nested row. I don't need that one, I need this one. And let's add another dot there. So dot, 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 dot. Essentially the idea is I'm going to put in a value that represents my starting value. And what we do is we populate the first entry in this matrix with the starting value, and then we just increment by 1 for every single preceding value. So start, then start plus 1, then start plus 2, and then start plus 3. So we're going to just populate this as an A range. Okay, so let's code that up. So I'm going to make an integer val, and we're going to initialize this to be start, and we're going to now increment through all of our rows and columns. And we're going to assign at index r and then c this value, and then we're going to increment the value. So as I mentioned, we want the definitions to be here, the function definitions here, but then we want to put the implementation in a separate file. So what I'm going to do is I'm going to do that right now. And then back here, we're going to remove the body, and we're going to include this nn.tpp file. And in main.cpp, we're now including this. Let's make sure that this compiles, first of all. So this compiles correctly. And now let's actually create a matrix. So I'm just copying the template here. And now create matrix. We need to template this by nr, nc, and then the type. And we need to pass in a starting value. I'm going to put in 0. Okay, so what is the type? Let's just make it simple, and we're going to make it an integer type. And we're going to make it a 2x2 matrix for the time being. So we have 2 rows, 2 columns, and we have an integer. So let's try compiling. Let's make sure this works. So it compiles. I just got a warning because I'm not using this matrix in any way. So now let's create a function to actually print this out to make sure that got populated correctly. So I'm going to make a function called print matrix, and it's going to be a void function because we don't return anything. And what we're going to do is we're going to pass in a constant reference to an array that is templatized. And just like the create matrix, it's going to have the exact same template. And we're going to copy this into nn.tpp. And let's start implementing this. Okay, so we're not going to do any advanced formatting for the time being. We're just going to do normal couts. So what we're going to want to do is we're going to want to include iostream. And using cout and endline. And we're going to increment, we're going to iterate over our rows and columns just like we did in create matrix. So for r equals 0, r less than nr, r plus plus, for int c equals 0, c equals c less than nc, c plus plus. And what we're going to do is we want to print it out in such a way that we print out all of our rows as if they were in one line, and then we only go to a new line when we get to another row. So what we're going to do is we're going to print out matrix at RC. We're going to pass in a comma afterwards and a space, but we're not going to put an end line. And then once we've printed out the whole row, this is where we're going to put the end line. And I don't need this the std. So cout end line. Okay, great. Now let's try compiling this, make sure that everything looks okay. And let's now call the print matrix on our matrix. And let's try running this. And we got 0, 1, 2, 3, as we would expect. Okay, great. Now in the next video, we're going to actually code the matrix multiplication, as well as all of the other points that I described in these comments below. Hope to see you there. All right, bye.